All right, now let's talk a little bit about where derivatives fail. And there's four different instances that derivatives fail, and let's just take a quick look at those four different things, okay? So let's just have some real quick graphs here, because it's easier to see these on a graph than it is to just talk about them. So I have four graphs here. And let's look at number one. Number one, anywhere we have a corner, we don't have a derivative. Okay? So on this particular guy, at any point that we have a corner, we are a no derivative action happening item. All right? So that's place number one. And where does that happen? At whatever those x coordinates are, where the corner point occurs, that's where we get no derivative at all. Okay? What other ways may we not get a derivative? Well, we could have what's called a cusp. And that would be a graph that looks like this. So graph your function. Take a look at that graph. If your function makes some sort of shape that looks like this, then right there where it folds in on itself, right there, at that value of x, we would have what's called a cusp. And when you have a cusp, you don't have a derivative. These guys over here are corners. Where you have a corner, you don't have derivative. Okay, where else? Well, what if we had some cool graph that did like this? Notice that right here, we have a vertical tangent line. Okay, right there we've got a vertical tangent line. At this point, right here, well, you cannot take derivative when you have a vertical tangent line. So at that x value where that occurs, you cannot have derivative. So no derivative at vertical tangent, no derivative at cusp, no derivative at corner. And a lot of these graphs are graphs you have to like put onto your calculator, punch it in, look at them, because it's hard to tell just from the equation whether you can take derivative over the entire graph or not. Now, the last one would be a discontinuity. So if I have some fun graph that does like this, and then we put in an asymptote, and then we finished our graph off with one of these puppies. Whoop. Let's make it red. Make it red. Then right here where my asymptote is, right there. See that right there? Those graphs don't touch. They don't touch. And since they don't touch, they are discontinuous. So wherever I'm discontinuous, I do not have a derivative. Okay? But now let's talk about something else, because it's important to understand. I have derivative all the way from here to here. I've got derivative from here to here. I got derivative from here to here. I've got derivative from here to here. I've got derivative from here to here. I got derivative from here to here. I got derivative everywhere except at these specific locations. And only those specific locations. Only at the corner, only at a cusp, only at a vertical tangent, and only at a discontinuity.